Imagine a world plunged into eternal twilight, where the very source of life, our magnificent sun, simply disappears. This isn't just a chilling fantasy, it's a profound thought experiment that unlocks fundamental scientific principles. For all you budding scientists and curious minds, let's embark on a journey to explore the catastrophic yet scientifically fascinating consequences of such an event. Our journey begins with a cosmic paradox. If the sun vanished, we wouldn't know for approximately 8 minutes and 20 seconds. Why? Because light, despite its incredible speed, takes that long to travel from the sun to Earth. This delay is our first science lesson. The finite speed of light, a cornerstone of modern physics. As the last batch of sunlight races towards Earth, the scene will change dramatically. After those crucial 8 minutes, the sky will turn into an inky black mass, followed by our planet. Night and day will become indistinguishable, and the moon, which only shines by reflected sunlight, will vanish from our view. Just moments before the final darkness, a visible aurora might briefly flare across the horizon, a ghostly farewell caused by the sudden disruption of the sun's magnetic field interacting with Earth's magnetosphere. But this immediate darkness is merely the prelude to a far greater catastrophe. Do you remember photosynthesis, the miraculous process by which plants convert sunlight into energy? This vital engine of life would grind to a halt. Without sunlight, plants and trees would rapidly perish, leading to the extinction of herbivorous animals, and subsequently the carnivorous ones that depend on them. This isn't just about food chains, it's about the very air we breathe. Oxygen production, primarily driven by photosynthesis from plants and microscopic cyanobacteria in our oceans, would cease. Our atmosphere, once a vibrant life support system, would slowly but surely become a stagnant, oxygen-depleted environment. This highlights the delicate balance of Earth's ecosystems and our profound reliance on solar energy. Within 60 minutes of the sun's disappearance, panic and terror would prevail. Our modern world, so reliant on electricity and heating, would face an immediate crisis. Power grids would fail as solar panels become useless, and the sudden loss of light would disorient populations. Many governments would struggle to maintain control, and chaos would ensue as humanity grapples with an unprecedented existential threat. Surface temperatures would plummet rapidly. Within 24 hours, the global average temperature would drop to approximately 5 to 7 degrees Celsius. In polar regions, the mercury would plunge even further, by 15 to 20 degrees. Earth scientists would scramble to understand the full implications and strategize for survival. While many surface microorganisms would perish, the deep oceans, insulated by vast amounts of water, would retain their heat for a longer period, offering a temporary refuge for some life forms. After 7 days, an oppressive darkness would reign over the entire planet. The average temperature on Earth would plummet to a chilling 17 degrees. However, pockets of warmth would persist around volcanic vents, both on land and beneath the ocean, sustained by Earth's internal geothermal heat. These hot spots would become crucial oases for any surviving life. Most warm-loving plants and animals would have already succumbed to the cold. The surface of the oceans would begin to freeze, a critical turning point. The plankton, the microscopic foundation of marine food webs, would die off, initiating a mass extinction event in the aquatic realm. Special scientific teams, if organized, would begin preparing deep underground or geothermally heated shelters, desperately trying to preserve the human race. 1 month after the sun's vanishing act, the Earth would be a truly alien world. The global temperature would stabilize around 30 degrees, and the planet's surface would be almost completely encased in ice. Yet, life, in its incredible resilience, would find ways to cling on. Some hardy plants, like conifers and certain extremophile bacteria, would persist around those volcanic vents, drawing energy from the Earth's molten core. Curiously, the thick layer of ice covering the ocean surfaces would play a vital, albeit grim, role. It would act as an insulating blanket, preventing the water beneath from freezing solid too quickly and slowing the loss of residual heat. However, the mass extinction of aquatic life, deprived of light and food, would continue relentlessly beneath this icy shield. After 1 year, a very thick layer of ice would cover virtually all of Earth's surface and water bodies. David Stevenson, a renowned planetary scientist, estimates the average temperature would reach a staggering 40 degrees. Despite this extreme cold, life would persist in the deep oceans, sustained by chemosynthesis around hydrothermal vents, a testament to life's adaptability. On land, human survival would be confined to highly specialized, self-sustaining underground bunkers or communities clustered around active volcanic regions, perhaps in places like Iceland. Stevenson's projections suggest that this icy state could last for thousands of years, eventually dropping the Earth's temperature to an unimaginable 160 degrees. At this point, even the most resilient surface life would cease to exist, leaving only the deep sea vent ecosystems as the last bastions of life. The sun's absence wouldn't just affect Earth. It would unravel the entire solar system. The sun's immense gravitational pull is what keeps the planets in their stable orbits. Without it, the 8 planets would no longer be bound. They would begin to drift outwards into the cold, dark expanse of interstellar space, potentially scattering, colliding, or even being captured by other stars or rogue black holes. Our Earth, now a frozen, dark wanderer, might eventually seek a new mother, another star to orbit. This cosmic dance of gravitational forces is a powerful reminder of the sun's role as the gravitational anchor of our celestial neighborhood. These are, of course, speculative theories, but they highlight the profound interconnectedness of our solar system. While our thought experiment is chilling, the sun's actual fate, billions of years from now, is equally dramatic, though less sudden. Our sun, like all stars, is on a life cycle. In about 5 billion years, it will exhaust its core hydrogen fuel. It will then swell into a massive red giant, expanding so much that it will likely engulf Mercury and Venus, and possibly even Earth. The temperatures on Earth, if it survives, would reach an infernal 5,000 degrees. Eventually, the sun will shed its outer layers, forming a beautiful planetary nebula, and its core will shrink into a dense, Earth-sized white dwarf star, slowly cooling over trillions of years. This stellar evolution is a fundamental concept in astrophysics, showcasing the dynamic lives of stars. Let's push our thought experiment even further. What if our sun suddenly transformed into a black hole? A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape. It forms when a massive star collapses under its own gravity, compressing its matter into an incredibly dense point. For Earth to become a black hole, it would need to be compressed to the size of a marble. Returning to our sun, if it somehow turned into a black hole, but without changing its mass, it would be compressed to a diameter of only about 6 kilometers. Crucially, its gravitational pull on Earth would remain exactly the same. This is a common misconception. A black hole's gravity is only stronger if you get very, very close to it. From Earth's distance, the gravitational force would be identical. So, if our sun became a black hole of the same mass, Earth would continue to orbit it exactly as before. However, on that day, we would witness the darkest, blackest sunrise of our lives, as the source of all light would be gone. The consequences for life would be identical to the sun simply vanishing, but the cosmic spectacle would be even more profound. This thought experiment reveals the incredible fragility and resilience of life, and the profound scientific principles governing our universe. From the speed of light to the intricate dance of gravity and the delicate balance of ecosystems, every aspect of our world is intertwined with our star. What other scientific questions does this scenario spark in your mind? How might humanity truly adapt to such extreme conditions? Share your thoughts and theories in the comments below. Dive deeper into astrophysics, biology, and geology. The universe is full of wonders, and asking "what if" is often the first step to incredible discoveries. Keep exploring, keep questioning, and keep learning.
Don't forget to subscribe to our channel and support the videos. I wish you to be healthier.